Hi, welcome to a brief introduction on the paper Solar Geoengineering and Solar Forcing 14 times greater than CO2. We're going to go over this 14 factor and show you the strong advantages of solar geoengineering compared to CO2 mitigation. The subtitle for this paper is Climate and Land Use Amplification in Global Warming Diagnostics. I'm Dr. Alec Feinberg. My bio is here. The paper is currently on ResearchGate and it's being submitted. So let's get started on the 14 factor. So the Earth's temperature is about 15 degrees C. To get to that temperature, some of the solar heating from the sun has to get trapped and kept in order to increase the temperature to get to the 15C. And from the Earth's energy budget, we can think of that as a amplification of by the greenhouse gases of the warming that comes in from the sun. So the greenhouse gases are made up of water vapor clouds, CO2 and other greenhouse gases, and about 19% of the greenhouse gases is CO2. So if we take that portion, the 19%, of the 62% of the greenhouse gases, we get about an 11.8% makeup for the total. So let's look at some of these numbers on a diagram here. So when the sun's energy comes in, it goes right through the greenhouse gases as it's light. Let's say it heats up a hot spot like an asphalt street. And we're going to use a nice number like 1 watt per meter squared. So that infrared radiation from the hot spot can get trapped by the greenhouse gases, and that's our amplification that goes on keeping the heat in, or the trapping. And if we were to cool that hot spot, we not only cool the 1 watt per meter squared, but we also cool the trapping, so we actually end up with a cooling of 1.62 watts per meter squared, which is the original heating that we would totally get. So mitigating the hot spot also mitigates its greenhouse gas effect. Now, on the other hand, if we were to remove just CO2, well, it does nothing to the hot spot, but we get some mitigation of this 19.19 of the 0.62. So let's look at that. So for a 1 watt per meter squared of cooling, we end up with that amplification, end up with a 1.62 reduction actually effect. On the other end, on carbon dioxide removal, we only get this portion of it, which comes out to the 0.118 watts per meter squared. So it's similar to the 11.8% that we just showed. To fully understand this number and appreciate it, I recommend you read the paper. There's a lot written on why this number has to be. But per watt per meter squared, when we take these ratios for this equivalent energy reduction, we get that 14 factor, which is what I'm trying to show here. Now, we saw that there was an amplification of 1.62, which is actually a greenhouse gas albedo effect. So that's part of the background climate. And then also there's a feedback amplification. We know there's feedback on our planet, like water vapor and some of these other effects. And that comes out to about 2.2 for an feedback amplification. And so the background climate actually comes up for these two numbers to 3.5, and we call that the albedo amplification forcing and feedback potential. So in my paper, that's what I call it. Now Alaska has a value of 4 as a surface effect, and urban heat islands have various factors, whether it's humid or dry. So some of the other findings in the paper is that actually urbanization, when we look at some of these amplification effects, we can find that we have about a 6.5% contribution from global warming, and that's true. If we reinterpret a lot of the satellite data, we can see that. So it agrees with also ground-based measurements that we have, as well as theory. So I've written a lot about this, and in this paper there's a lot of information demonstrating that. Diagnostics, there's a linear model instead of a saturated model, which shows that the greenhouse gas in the AR6 a little bit overestimated by about 39%, and CO2 about 29% too high on its effect. And we can see that some of that could be taken up in more room for the forcing that is done by urbanization, and the planet is losing albedo strength. There's a loss of reflectivity that's observed. Now, governance implications from what we just talked about: solar geoengineering should be considered a premier mitigation tool. Solar forcing, the albedo also is a very strong effect, and so it makes things much worse than CO2. So we need to focus on albedo preservation and have to good habits in urbanization for roads, roofs, vehicles, and building sites. These remain unregulated. It's very bad behavior not to have that, and I've been a proponent of that. The Paris Accord should be expanded to include albedo and goals and ban dark surfaces. We need albedo Arctic protection is especially urgent. So in conclusion, we see that solar geoengineering and forcing are both 14 times more efficient than CO2 changes on an equivalent energy basis, and we did that for that 1 watt per meter squared. So the Earth responds more strongly on the front end to protecting there than on the back end for the long wave absorption by the greenhouse gases. So that shows you the difference. It also helps explain Arctic amplification, which has gone over in my paper. So I want to thank you for listening to this brief introduction and hope you get a chance to read the paper.